Hello, and welcome to the Bolt and Helix Autocad tutorial presented by the Columbia Basin College's Engineering Technology Department. Designing bolts and helixes in Autocad can be a rather daunting task when first beginning, but hopefully, throughout this tutorial and by the end of it, you will have developed the skills to develop your own 3D bolts. Like most projects, it is important to begin by finding your dimensions. Even though this can be presented in a variety of different ways through different mediums, it is important that you find these 6 bits of information, as they will be necessary in developing a bolt through this tutorial. Those 6 bits are the hex diameter, the bolt head thickness, the bolt size, the bolt's length, the pitch of the threads, and the height of the threads. For today's tutorial, we'll be using the numbers here to design our own bolt, so it is important to write this down, although I will be referring back to it throughout the tutorial. To begin, I'll start by drawing a circle at the 30mm diameter. Next, I'll take a polygon and I will draw the 6-sided figure for our bolt's head on the top. Next, we'll go to give it some depth. Our bolt head was 8mm thick, so we'll go ahead and set it for 8. We'll move this circle down just so that we can find the center easier and as part of our next step here. Next, you'll want to find small details such as the tapered head and the bolt chamfer. Although these will never be the same in most circumstances, for the simplicity of this tutorial, we'll set both the tapered head and the bolt chamfer at 45 degrees. Don't worry about the bolt chamfer too much right now. We'll get into that later. So to set the tapered head, you want to begin by extruding, and then right-click. You'll select Tapered Angle, and as you can see, as I move from left to right, my value goes from negative to positive. The max will be negative 90 to 0 to positive 90. So in order to get a result of 45 degrees in the appropriate angle, we'll want to go negative 45 in this circumstance. To ensure that we cover the entirety of the bolt, we want to make sure that we go over 8mm. So just simply select any value over 8 and hit enter. As you can see, we have now created 2 separate objects, and this isn't necessarily what we want. What we want is to take one intersected object, so we'll take intersect and subtract it from the other. We do that by selecting intersect and then selecting both objects. And as you can see, the top of our bolt now has a nice tapered edge, allowing for easy use on the tools. Next, we'll want to go ahead and get started on the bolt. The bolt size and the bolt length are listed here. The bolt's length will be 50, while the size of the bolt will be 10mm at its maximum. So coming from the center of the top, we'll go ahead and draw a line of 50mm. Next, we'll create the bolt's body and go ahead and set that for 5 radius or 10 millimeters in diameter and extrude that throughout the entire 50 millimeters. Now if you remember before, we talked about the bolt chamfer. The bolt chamfer is like the tapered head and allows for the bolt to be more easily threaded into a nut. And as you can see, that nice finish there, we'll try and put something like that on the top. So coming from the top, we'll go ahead and select our chamfer command. Once you've done that, you'll select your object and hit OK. Now, if you remember a tapered edge, we were able to select an angle. A chamfer is not the same. Although we want a chamfer of 45 degrees, we can only input how far in from the outside and down from the top this chamfer will occur. So in order to get a degree of 45, we will simply be doing 1 millimeter down from the top and 1 millimeter in from the side. We will select our top and then hit enter. And as you can see, we now have a chamfered top to our bolt head, or our bolt top, which is 1 in and 1 down from the top. After you've done that, we can go ahead and begin the helix. The helix radius will be the same radius as your maximum radius, which is 5. That is the case for both the top and the bottom of this particular screw. Next, we'll want to consider how far this helix will be running along the bolt. It is not always the case that the helix be running throughout the entirety of the bolt, but for the simplicity of this tutorial, we will be keeping it across the whole body of the bolt. Next, you'll want to consider the pitch or the turn height. This is how much space is between each of the threads, which for this tutorial will be 2 millimeters. So we'll go to the turn height and enter our 2. And as you can see, we now have a much more consistent spiral throughout our body. Once you have decided, go ahead and select throughout the whole body the 50 millimeters and hit enter. After you've completed your helix, it is now time to begin working on the cutout piece that will run along the entirety of the helix. The cutout piece will come in and it will cut out the finished body in the pattern here and will give us a screw-like pattern. This cutout piece is really just a triangle made up of this series of equations, making up the base, height, and the rounded fillet top for the triangle. You'll want to begin by calculating for the base of this triangle, which is simply pitch minus the crest. The crest is equal to p over 8. So a simplified version of our equation would be p minus p over 8, or 1.75, which we'll go ahead and add that to our drawing now. You'll want to switch your viewing plane to ensure that you draw the cutting piece on the correct plane so that it can be placed on the helix. Next, we'll want to consider the height of our triangle. This is h minus h over 8. As you can see, h is from tip to tip, but we don't want the tip there, and that is h over 8, which is where we get the h minus h over 8. If we were to go over the h over minus h over 8, we'd be going over the major diameter, which would make it bigger than our bolt. And as you can see here, our h is 1.75. So our 1.75 minus that 1.75 divided by 8 will be 1.531 millimeters. So we'll take that 1.531 millimeters and go ahead and add it to the height of our triangle. And go ahead and close that triangle up. Now we can begin working on the fillet for the top. As you can see, it's not a perfect point for our cutout piece either. There's a rounded piece. So we'll take the h divided by 6 to find the distance from the point to the top of our fillet. And then we'll take p divided by 4 to find the two sides. And after doing h divided by 6, we get 0.2917 millimeters. So from the top, we'll go 0.2917 and hit enter. Then p divided by 4 will be 0.5 millimeters. So again, we'll come in and draw a line of 0.5. And as you can see, it doesn't fit exactly right, but we're trying to make an arc, so we'll go ahead and move it over. And this should give you the 3 points to make the fillet for your cutout piece. So now we'll go up, pick the 3-point arc command, and connect our points. And from there, we can go on to trim up our tool. Next, you'll want to make sure everything is joined. If it doesn't join, like this, just simply move one of the arms back and forth. It is absolutely necessary that the entire piece be able to be joined. For this, we'll be going to make a 3D object next. Once you've ensured that it is one solid joined object, we can now take the cutout piece and run it along our helix. We'll do that with the sweep command. Select sweep, select the tool, and then select the pattern, and hit enter. And as you can see, our cutout piece has now run along the entire pattern of our screw. This has actually created two separate pieces though. And this is still not exactly what we want. We will be taking one piece and cutting it away from the other. So let's go ahead and do that. And there it is, your very own 3D bolt. I hope that you enjoyed this tutorial. If you have any questions, please feel free to contact the Columbia Basin College Engineering Technology Department. Thank you.